Hi everyone and welcome to Electrical Know-How. Today we're going to be taking a bit of a look at calculating the total resistance inside of a series circuit. So first of all, let's take a bit of a look at a series circuit just to make sure that we're all looking at the same thing. So the series circuit will look very similar to this one here. So the characteristics of a series circuit is that it has one single path for the current to flow on. Alright, so we can have the current flowing in here and then back out there. The same over here, it's going to flow in and along and then back out to the source. So that is a series circuit. So we need to make sure that we're not looking at other types of circuits, such as a parallel circuit or something like that, where we've got more than one way that the current can flow. And there's a special type that I want to show here just to make sure that we're not looking at these ones. So these type of circuits are called a series parallel circuit. And that is because they've got parallel pieces like here and over here, but they've also got series pieces. So we've got series in here and here, and we've also got series in here, here and here. So these ones here are a special type of circuit, and you just need to know how to do a few extra things if you want to be able to calculate these ones. So there's 3 videos you're going to need to watch to be able to calculate problems like these ones. So that is calculating resistance in a parallel circuit. You're also going to have to watch the video you're watching now, which is calculating resistance in a series circuit, and then finally calculating the resistance in a series parallel. So if the problem that you're trying to solve, if it looks like one of these, then you're going to need to check out just a couple of extra things in order to be able to find the solution to that one. So let's get on with the show a little bit. Let's start with some facts. So, and fact number 1 is adding a resistor to a series circuit increases the total resistance of the circuit. So it sounds a little stupid that of course more resistance equals more resistance, but we're just comparing the series circuits with the parallel circuits. So, and trying to understand that relationship between resistance in the total scheme of things for that type of circuit. So inside of a series circuit, if you add a resistor, you are going to increase the resistance. Let's move on to fact number 2. Again, this is a little bit of a contrasting thing with a parallel circuit, but inside of a series circuit, the total resistance is going to be more than any individual resistor in the circuit. So we can see in our example here that we've got 100 ohms in total, and the two resistors in the circuit are 50 ohms and 50 ohms. So our 100 ohms is more than any of these individual resistors. Let's move on to point number 3, and that is choosing the right formula depends on the information that you have. So there's 2 formulas that we use, and we're going to run through those ones in a minute, but they both come down to what information you've got on hand. So let's check out our first formula, and it is Ohm's law. Lots of people have heard of Ohm's law. It is a basic electrical principle. It's really simple, which is great. And it, in this particular adaptation, is R is equal to V over I. So resistance is equal to voltage divided by amps. Okay, so this is a really quick and easy tool. It's something that's very easy to remember as well. And you're going to use it all the time in electronics, but let's take a bit of a look at an example here, and we're going to get to see Ohm's law in use. So we've got 3 resistors here, 1, 2, 3, and none of them are marked. We don't know what any of these resistor values are, so not very helpful there. But what we do know is that for this circuit here, we've got 6 volts and we have 2 amps. So what we can do is we can use Ohm's law to figure this one out, and so we can get our 6 volts and we can divide it by our 2 amps, and that's going to give us a total of 3 ohms of resistance. So even though we don't know what each individual one is, we can say that the total resistance for this circuit is the 3 ohms that we just talked about. So let's move on to our second formula. So the second formula, it's a nice easy one, and it just says that resistance total, or total resistance, is equal to the first resistor, R1, plus the second resistor, R2, plus the third resistor, R3, and then R4 and R5 and R6, and as many resistors as you happen to have in your particular scenario. So it's nice and easy to do. There's nothing very difficult about this one, but let's take an example just to make sure that we've got things right. So in this example here, nice simple maths, we've got R1, R2 and R3. So R1 is a value of 10 ohms, R2 is a value of 20 ohms, and R3 is a value of 30 ohms. So what we do is that we plug that into our formula down here, and we can see RT, or resistance total, or total resistance, depending on how you'd like to phrase that one. And that is R1, which is 10 ohms, plus R2, which is 20 ohms, plus R3, which is 30 ohms. So 10 plus 20 plus 30 equals a total of 60 ohms. So for this circuit that we're looking at here, we have a total resistance of 60 ohms. Now let's just check out another example just to make sure that we've got this one pegged. So in this example here, we just have the two resistors. And so we can see here that R1, our first resistor, has a value of 200 ohms, and R2 has a value of 1000 ohms. So we've just got the two resistors here. So again, we bring those values and we put them in our formula. So the total resistance is worth R1 at 200 ohms plus R2 at 1000 ohms, and add those two together, 1000 plus 200 is 1200 ohms. So the total resistance inside of this circuit here is 1200 ohms. So it's nice and easy. We can see that calculating the total resistance in a series circuit is a pretty easy thing to do. But before we go, let's just check out one final example here. And so we are going to be having a bit of a look at what you do if you've got your total resistance, but you don't know what all of the resistor values are. So in this case, and we'll just have a quick look at the example in a second, but we've got the total resistance here, and we've got a resistor that we don't know. So the resistor we don't know is the total resistance minus the first known resistor, plus the second known resistor, plus the third and the fourth, and as many as we have. And we can use the total resistance and take away all the other ones that we know, and the remainder should be the missing resistor. So let's take a bit of a look here at our example. In this one here, which is the exact same numbers as the examples we used a couple of slides ago, is we have a total resistance of 60 ohms, and resistor number one, we don't know what it is, it's a question mark, so we don't know what the value is there, but we do know that resistor number 2 is 20 ohms, and that resistor number 3 is 30 ohms. So what we're trying to do is find out what is this missing resistor. So what we can do is we can take our total resistance, which is 60, and we can take away the 20 ohms for this one here that we know, and we can take away the 30 ohms for this one here that we know, and that should leave us with the remainder of the one that we are missing. So 60 ohms, take away 20, take away 30, is going to leave us with 10. So resistor number 1 is 10 ohms. So we can see that when we've got the total resistance, we can also work that backwards and find the resistance for a missing resistor as well. And that is the end of the show. So now you should know how to calculate the total resistance in a series circuit, and we hope that helped you out.